Hello and welcome everybody. Russell will be doing all the hard presenting today, but I just wanted to give a little color and help kick this series off. It's just about 2 months ago here now that we were in Singapore at the Year in Infrastructure. During the Year in Infrastructure, we had live streaming and recordings of our keynotes, and I think it was the first time ever that we live streamed the awards gala. There are so many presentations that go on, though, where information throughout the company is provided, and it's only been made available to those users who are actually in attendance. And we've recognized that the international travel can be difficult, that we have so many users that really should be able to benefit from the information that we're providing. And so we've recognized the need to share those materials and presentations and information on a much broader basis. And so over the coming weeks here, we will have 3 presentations that really build on each other, and I hope that you're available to attend all of them. We start today with what Russell will do, talking about digital twins in transportation and how we really need to get to a road network, or it could be rail network, digital twin. In a week then, we'll follow that up, where given a network digital twin, Andrew Smith will show how we can get into really applying operational analytics better on top of those kind of network models. Then we have a couple weeks of holidays, and on January 8th, Ralph Chopin will have the 3rd in the related series here, looking about when we have the digital twin network model, when we have data about what's happening operationally and the condition of our assets, when we understand what we have available in terms of the bulk of our funding, we can get into making much more informed strategic asset management decisions. So they are all related. You don't have to have heard one for the next one to make sense, but I do encourage you all to participate in this whole series, and hopefully we can share a little bit about what we did provide at the Year in Infrastructure, and give you the glimpse into where we really see this going in the coming months and year here for us. So with that, I'll kick it over to Russell to kick off here.
Thanks, Dan. So as Dan just mentioned, I'm going to be talking about the 4D digital twins of your transportation network. So to start off with, what do we mean by a transportation network? And so we can start off, we can think of it as the major routes. It might be the ramps that form part of the network. It could be the local road network, or it could be the trails that are associated with that network. We can also look at different types of transportation. So the network may relate to the light rail network or general rail network. It may even consider things like the bus lanes. So these are just examples of the different types of network. And typically we can think of these as a connected network when we start looking at the nodes that connect them to each other. And then when we start looking at the different types of network, we can relate to these as a multimodal network. So the more information we have about the networks, the more types of information we can collect to start getting some analytics against all of the networks as they relate to each other. So what is the digital twin of the transportation network? It's not just the topography, as you just saw in that map, and it's not just about the CAD model. It's about all of the information that relates to the network. So it's a combination of that network topography and the CAD models, but it's also information such as photographs and LiDAR information. It can also be information that relates to the operational aspects, such as borehole records, inspection records, condition information, and maintenance records. It can also relate to any other information about the status of those assets and information on the network. So that's information that's coming from IoT connections. So in total, the digital twin of a transportation network is any of the information that enables us to make informed decisions about the network and its associated assets. So why is that digital twin critical? Well, it's needed to meet the industry challenges that more and more of you are facing. So if we consider things like reporting compliance, so in the developing world, HDM4 for information and HPMS reporting that the US DOTs have to face. So this is being able to get all of that information and being able to assimilate it and use it for those types of reporting. We also need it for user expectations. So as information becomes more freely available to members of the public, we need to increase our reliability. We need increased confidence about the decisions that are being made, and we need to start looking at behavioral patterns, such as the expected lifespan versus the actual lifespans. We've also got an increased network usage, so there are more vehicles on our roads. Those vehicles are becoming heavier and longer, and there's also increased congestion, which also becomes more visible to the public. There's emerging trends that are starting to cause challenges. So although ISO 55001 is more about the processes that we should perform, we're also then having to use those processes to start developing asset management plans. And some of those asset management plans are putting more pressure on us to do things like risk-based prioritization and cross-asset optimization. So being able to analyze the data better so that we can do those types of optimization. And then there's also the operational aspects. So the infrastructure that we have is beginning to age. So this means that we're seeing recurring faults and increasing costs. We have limited resources for that operational aspects, and we also have reductions in workforce and expertise. And then we have the decisions of maintenance versus renewal. So all of these all of these challenges combined mean that the digital twin makes some of those challenges easier. So when we consider the digital twin, what does it need to deliver? Well, first of all, it needs to provide easily accessible information, because that's necessary so that we can deliver accurate and up-to-date decision support. We need accurate and timely information for data analysis, so that we can start looking at the growing trends of a more preventive and predictive approach to asset management rather than worst-case first scenarios. And then we also need it for historical information for transparency and insight. So these are terms that we're beginning to hear more and more about in terms of the insight to make sure that the decisions we've made were the right ones. So AssetWise provides the capabilities to maintain, manage and analyze and report against your transportation network, delivering all of those capabilities. So at Bentley, we start with a network. And some of the questions we're often asked is, why can't I just use the centerline geometry? Well, let's look at what the network consists of. So first of all, the network itself is a complex asset. And that's because it's a network of connected and interrelated assets that work as one. It has numerous characteristics that change along its length, and it has numerous point or linear assets associated with it. So although each of those assets are individual items that we need to manage and maintain, when we put them together, they form the network. So each of those assets dynamically change continuously along its length. The network itself has multiple connection points to other networks when we look at the multimodal type networks. And the network itself can be referenced in different ways. So for example, we might reference assets as a location from the start of a route, or they might be referenced as a point from a bridge. And those routes might be overlapping. So in the industry, we refer to those as multiple linear referencing. So you can see we're not just looking at a single asset. We're looking at something which is a whole bunch of information that works together and is complex. So a spatial geometry approach simply can't manage those characteristics like a digital twin can. So let's use another example of why the spatial approach doesn't work. So if we take this first dot on the red dot on the left-hand side, how do we know whether this asset that's located here is on the road or the rail network? And if we look at the other dot on the right-hand side, how do we know if that asset is on top of the bridge or whether it's under the bridge, as you can see in this photo? So we need to be able to relate the information to the network and not just as it exists spatially. So the video that you're seeing now is from the AssetWise linear referencing services. So this is the tools and capabilities within AssetWise that enable us to manage and maintain the centerline topography of the network. But AssetWise linear referencing services is much more than just managing that network. So in this case here, you can see that the user is managing to identify a route that exists on the network. We can have overlapping routes on the system, so this is what we refer to as multiple linear referencing. And what the system also provides is the capabilities of performing dynamic segmentation of network. So this is how organizations like Department of Transportation organizations like Oregon DOT can perform their HPMS reporting. AssetWise linear referencing services also enables us to manage events against the road network. So we can identify information such as speed limits and condition information along the network. It also enables us to manage assets on the network. So we can locate those assets against any route that we want to, and then we can also identify those assets where they exist as what we refer to as cross-sectional positions. So whether they're in the left lane and the right lane and so on. So AssetWise linear referencing services is really where we start managing and maintaining the network. One of the things I mentioned is that we can also perform dynamic segmentation against the network. So what dynamic segmentation enables us to do is model the network as it exists in the real world. And so this starts making that complex network much easier to maintain. So for example, if we have a speed limit or a functional class, we can identify that on the network exactly as it exists in the real world. We don't need to identify the smallest chunks of the network to relate that to. And then what we have is capabilities such as dynamic segmentation that enable us to segment this network up any way that we want to so that we can perform analysis and reporting. So for example, if we wanted to identify all the locations on the network where the traffic volume is greater than 1,000, where the condition is less than 2.5, where the speed limit is less than 60, and where the functional class is equal to 6, we can run a report against the network, and we can dynamically segment all of those changes, and then we can identify the locations on the network where all of those items are valid. And then that information is available for us to report against. So using the AssetWise linear referencing services and capabilities like dynamic segmentation, Oregon Department of Transportation have managed to perform their HPMS reporting. And HPMS is a really good example of why you need a digital twin of your transportation network. Because what they do is that they take information from many disparate sources, they use all that, the road network to bring all of that information together, and then they're able to extract, segment the road network, and produce both their tabular and their spatial reports. And the AssetWise system has enabled Oregon to reduce their production costs of the HPMS reporting. It's increased the quality and accuracy of those extracts. It leverages corporate asset data from all of those disparate systems, and it's enabled them to provide on-time HPMS submittals for their federal reports. So we've talked about AssetWise linear referencing services in the network, but the Transportation Network Digital Twin also includes other information such as assets, features, and events on the network. Here we're going to see a video of the AssetWise ALIM capabilities. So in this case here, the user can select the type of asset they're interested in, and then they can perform a search on the map using the spatial tools. So in this case here, the user's drawn the polygon and they've identified that there's a bridge at this location. So here's the bridge, and you can see down the left-hand side, these are the components of that bridge. So in this case, the multiple decks and spans of that bridge. When the user clicks on each of those components, you can see on the right-hand side the asset information that relates to that. AssetWise ALIM also enables us to identify information such as inspections and activities or assessments that we want to perform against the bridges. So in this case here, as the user clicks through assessments, they can look at all the assessments or all the inspections or all the maintenance that's been performed against this individual bridge. If we select on any one of these inspections, we can see the information that's been recorded, and we can record additional information against those. We can also see the tasks that are required as well. So AssetWise ALIM enables us to identify workflows. So once we've performed an inspection, it tells us what the next piece of the workflow is for us to work through on this. And once we've identified those tasks, we can also record other information such as the defects and any work requirements that are required to repair that defect. So AssetWise ALIM enables us to manage the information, the operation information against the assets and the network. Highways England are using AssetWise ALIM for their structures management. So some of the outcomes of them using that is that it provides them with the ability to perform spatial and network management. It provides the asset information management for their structures and roadway assets, enables them to perform their inspections and work management, and it also provides reporting such as bridge condition reporting. So now we've seen some of the operational aspects of the AssetWise transportation network. It also enables us to perform analysis and interoperability. So in this case here, we can now look at AssetWise operational linear analytics. So in this case here, we can see on the left-hand side information about the network in the map at the top left-hand corner, and we can say information about the network itself. What we can do is that this is time-based information, so we can see information about track conditions over time, and the user can then look at surveys that have been performed. So by clicking on the bottom left-hand side here, we can see information about the design, and if we are interested in that survey, we can click on it, and through the connected data environment, we can then look at information about that survey in ProjectWise. We can also associate other information to the network as well. So in this case here, we can now look at the point cloud information that's stored against that piece of network, and we can view that in the map as well. This then gives us some 3D capabilities from that LiDAR data. So using the linear analytics capabilities, we're able to look at time-based information that's going to enable us to look at conditions and actions that have been taken over time, so that we can then perform analysis against the network to identify if we're making the right decisions. So that refers back to the insight that I referred to at the beginning of the presentation. AssetWise also uniquely extends a transportation network twin to a 3D visualization. So if we take a look here, we can see information about the network, so in this case a rail network, and here we can combine eye models with reality data from context capture. So now we have the 3D visualization of the network. We can zoom in, and then we can look at that eye model information with AssetWise ALIM and reliability information. So by clicking on any of the features inside this eye model now, we can see information down the bottom of the screen that relates to the AssetWise ALIM information. So this can be information about the operational aspects, inspections that have been performed, or any other asset information that's available. And because all of this information is also related to the network, we can then use geospatial coordinates to display that information accurately within the 3D digital twin. On the right-hand side, we can see the information that relates to that. So in general, what we've just gone through today is really how the digital twin of the transportation network enables us to manage all of the aspects of the network. So it's information about the network itself, all the information that relates to it, such as operational information as well. And then when we start displaying that in the 3D context, we have all the information that enables us to provide improved decision support. So as Dan mentioned, this is the first in a set of webinar series. So this was the first one today on the digital twins. We'll also be having Andrew and Ralph, my colleagues, do further presentations about making better decisions by turning linear data into actionable information. And then Ralph will be doing a follow-up on the next generation of strategic asset management for transportation.